Hi, my name is Marc and this is the first of a series of training videos that I will be creating in order to help teach students of the teams that I will be working with in the upcoming 2015 FRC season. My hope is that these videos will be more effective than just in-person sessions alone. If any of you notice me teaching or doing anything that you feel is incorrect, then please let me know. Please don't worry about hurting my feelings. I believe a lot more in the value of constructive criticism than the value of just being nice. So first off, who am I and what is my history in FIRST? So I told you a little bit about what my name is, but what is my experience in FIRST? So I'm an alumnus of Team 973, the 2011 World Champions, and I was on that team all 4 years of high school from 2010 to 2013. Now this last 2014 season, I helped mentor a rookie team 5102, and this is actually a CAD file of their 2014 robot. Should be somewhat familiar. If you went to a couple of the California regionals, you might have seen this robot. If not, don't worry about it. So one of the reasons I'm creating this video is that one of the teams I'm going to be helping this upcoming season is Team 3925, and they have a lot of students on their team, at least compared to the teams that I've worked with in the past. So Team 973, across the 4 years I was on that team, they had about an average of 14 students. So when it came to teaching students things like CAD or programming or other FIRST-related tools, it was relatively easy. You could have one-on-one time with each student, and because there's only 14 of them, you could spend one day teaching one student, and it'd only take 14 days to do it all. But with a team like 3925, there's 70 of them. I think there's a little over 70 of them this year, and that's really not practical to do one-on-one training with each of them. So I'm going to be creating these videos in an effort to hopefully do maybe lecture-style lessons where I teach multiple students at a time, and then also for the students that are more interested in certain topics, doing one-on-one. One thing I remember about when I learned how to do SolidWorks on 973 was that a lot of the information was very hard to remember, especially later that day or later that week, or even in the months afterwards. Sometimes it's really hard to remember. Man, I saw my mentor do all of these things in SolidWorks, but man, where is that tool? Like the measure tool, where is that tool? And those things like that, I eventually started having the muscle memory to know where everything was, but it was really hard. So I'm going to try and do these videos as close as possible to reflect the lessons that I do with the students. And so hopefully after I do the lessons, students can go to these videos and maybe pause it halfway through or whenever they need to and see exactly how I did something if they don't remember it. Now if you're a student from another team, then you feel free to join right in. I don't want to be exclusive to people who are on teams that I'm not working with. So please, by all means, join right in. If you have any advice for any future lessons or any changes that I can make, please let me know. So this is Team 5102's robot in CAD. It was very useful. I'm doing it all in CAD because, especially for a rookie team, it was really hard to try and grasp, okay, we're going to make a tube like a side rail, and it's going to be, I think this one was 30 inches long, and they're going to mill several holes in it. You can see we had the half-inch hole pattern, pretty standard to 973 if you're familiar with that. And so having the ability to do it in CAD and then make a CAD drawing to reflect that was really easy. And it really helped a lot with the kids who were learning how to machine. They could see it in CAD before they machined the part, so they could see kind of the light at the end of the tunnel. So what else do we got here? So this last summer, I made this kind of a prototype drive in CAD just by myself, because I wanted to see two things. First off, the geometry of making an octagon-shaped drivetrain. 971 debuted their octagon-shaped drivetrain last season. They were very successful with it. 973 in this last off-season, they tried it out with the West Coast drive. Kind of similar to how I'm doing here. If you haven't seen theirs, please go check it out. I'll put a link to it in the description below. So this was kind of just seeing how that would work. It's not totally precise. As you can see, I've got this gearbox here. I didn't reflect it the way I should have, so when I reflected or mirrored the parts over to this side, it didn't quite line up correctly. But whatever, it's not too important. But going into this gearbox, where is it? Here it is. Going into this gearbox, you can see that a lot of these parts are custom, and a lot of these parts are off the shelf. For instance, this is the West Coast Products bearing block for the West Coast Products gearboxes. So if you've used those in the past, you should be familiar with this piece. And also the Vex Pro sprockets, the Vex Pro gears, and West Coast Products shifters. And of course the sim motors and the shifter that West Coast Products and Vex Pro uses in the gearboxes. And one thing I did with this gearbox design actually is I wanted to see how small I could get it. One thing you'll notice with the Vex Pro, or sorry, not the Vex Pro, the West Coast Products 3-sim drive is they have an idler gear that sticks the third sim, this being the third sim, on top of the other two sims, which makes it a very top-heavy gearbox. So one thing I wanted to see was using minimalistic gears in this gearbox and then seeing what geometry I could get them to fit together with an idler gear just off to the side here. So it's not even it's not in line with it. That's why it's not symmetric across both sides. You saw in the full assembly, this side doesn't quite line up, because to make it line up I'd have to make either a new assembly, or I'd have to modify the assembly so that way it could reflect both configurations of the gearbox. And this is all stuff I'm going to go through in some of the CAD tutorials, but I'm going to obviously start with some more basic stuff than this upper level assembly where you have, like, for instance, the entire robot. And I think, yeah, this one you can articulate the entire arm back and forth. So that's one thing I'll discuss, is how do you get the arm to move back and forth without breaking or without overextending. I don't know if will this do it. No, I think I fixed that issue. Sometimes you'll have arms that will overextend beyond what they would do in real life. What are some other things I've done? So this is just real quick, a wheel. This is a 3-inch wide wheel that would accept some nitride tread on top, and then with a bolt pattern, so you could bolt that tread onto there. What else? So SolidWorks doesn't have to be specifically for FRC purposes. This is a high school physics project that I worked on when I was a senior, and this was something where the teacher gave us a motor, just a really simple low power motor, and they said you can't apply any more than 5 volts to it. So we put 4 AAA batteries in here. You can see them kind of like there. And the goal was to go 10 meters, or to get it to go 10 meters, and the faster you go, the more points you'd get. So I designed this all within SolidWorks, and then had it 3D printed, and I could not have done that without the use of computer-aided design. So this was very useful for that. And then what else? This is a drawing, so I'll be teaching, one of the first things I'll be teaching is creating a drawing, a simplistic drawing. Not necessarily like this. This is actually the drawing I made of my room. So you can see I'm representing my bed, my nightstand, my workbench, and my computer desk, all just with really simple shapes and in a really simple drawing. And there's quite a few dimensions in here that may look a little complex and confusing, but don't worry about that. I'll teach you how to interpret these in the future. So, and this is also a table that I wanted to fit in my room. So I have this just kind of free floating right now, and I can move that around. See, oh, it will not fit in between my bed and my workbench, and I can say, oh, it'll fit in the middle of my room, or it'll fit over here in this corner, or whatever. So it's really useful for other things in your life as well, especially if you go on to work for an engineering company or firm that uses SolidWorks, because then you can go in and not only can you say make a drawing, if you're good at making drawings of something real fancy part, you can go in here and actually show that the geometry will work. And this is actually, I took it a step further. So this was actually a desk that I wanted to buy for my computer station, and I wanted to see how all my stuff would fit on it. So I started with a simple drawing, and then I decided, oh, I'll just make it a 3D representation. And you see, it's very basic. The legs look more like walls, and this right here is actually kind of a sliding tray that goes in and out, but I made it just like on a solid piece. It doesn't have to be very detailed. This is very simplistic. And of course, here's my monitors, and you can see they look like big blocks. In reality, they look a lot better than blocks, but for this purpose, I didn't have to put that level of detail in there, and it was really useful. So now I can say, oh, my monitors will fit on there. I could put something right up against each side, and I won't have to worry about it. And then also here's my computer for size reference. So that was really useful. And yeah, so anyway, I will eventually be going into how to make advanced models like this, and some of the tools that you can use to make these advanced models. One of the last things I think I'll teach is pocketing. And I know there are a lot of other tutorials on kind of assemblies, using off-the-shelf components. I know 973 RAMP, the remote remote assistance mentorship program that Adam Hurd from 973 does. If you haven't seen any of those videos, please go check them out. They're awesome videos. Those are geared more at teaching students from other teams or mentors from other teams how to do things with very low resources. And I think they're fantastic videos. I tell all of my students that they should go watch those, so please go watch those too. And because there's a lot of things that Adam teaches in those videos that I may not cover so much in these videos, just because you don't need to do two things at a time, or you don't need to teach things twice, kind of thing. And this isn't meant to be a copy of that. This is again meant more to be kind of to assist the students on Team 5102 and Team 3925, and maybe and if I'm going to help any other teams with teaching them CAD or other skills, so that they can go back after the lesson, go back to this video, and perhaps maybe learn a little bit better, or maybe be able to remember some of the things I taught them a little better, and hopefully it'll stick with them a little better. So so with that, if you have any suggestions, please let me know. I'll try to make these as good as I can. I'll try not to take too long. It looks like this video is 14 minutes almost, so sorry if I take too long, but I just get so excited sometimes. Alright, thank you so much for your time, and let me know if you have any suggestions, and feel free to contact me. My name is Marc Stolmeyer. If you're on Chief Delphi, you can find me here, Marc S. Just send me a private message anytime. You can, and if you have any questions about me or about anything that I teach or anything you want me to teach, go ahead and contact me here, or you can also contact me at marcstolmeyer@gmail.com. So go ahead and contact me here. If you can't see that, I try to run these videos at 1080p. Maybe YouTube will make it smaller than that. Hopefully you'll be able to see it at 1080. And let me know if you have any problems seeing it. But feel free to email me at marcstolmeyer@gmail.com. Just title it your videos, your CAD videos, or whatever, and I'll be happy to answer any questions you may have. Thank you so much for your time. I'll see you next time.